Welcome to Ask and Learn.
Hi everyone, so what we have is a 0.5 pound ball that is going along a vertical circular path given by r equals 2 times rc cos theta. And we know that the rod, or the angular arm, has an angular velocity of 0.1 radians per second and that it's accelerating at 0.8 radians per second squared. What we're asked to solve for is the force of the arm on the ball when theta is equal to 30 degrees, assuming that the RC is equal to 0.4 feet. And the way that we're going to be doing this is using our knowledge of tangential and angular motion, and using free body diagrams to develop equations of motion to solve for this force. So let's go ahead and get started. First thing we're going to do is we're going to say that r is equal to 2 times rc cos theta. And since we know rc is just 0.4 feet, we can say that r is equal to 0.8 cos theta. Therefore, r dot is equal to negative 0.8 sine theta times theta dot. Fix this theta here. And we also know that r double dot is equal to minus 0.8 cos theta times theta dot squared minus 0.8 sine theta times theta double dot. So what we can do is, knowing our knowledge that at theta equal to 30 degrees, we know that theta dot is 0.4 radians per second and that theta double dot is equal to 0.8 radians per second squared. We can go ahead and solve for our r dot, and r double dot. So by plugging in all the information we know that r is just going to be equal to 0.69 feet. We know r dot is going to be equal to minus 0.16 feet per second. We know r double dot will be equal to minus 0.431 feet per second squared. We can take all this information and plug it into our equations for acceleration in the radial and theta direction. We know that ar is equal to r double dot minus r theta dot squared, which gives us minus 0.5417 feet per second squared. We know that a theta is equal to r theta double dot plus 2r dot theta dot, which is equal to 0.4263 feet per second squared. Now what we can do is draw our free body diagram of our block. So here we have our mass, here we have the theta direction, and here we have the r direction. So we have our normal force, and we know this angle is 30 degrees. Call this normal force. We have this force FOA, which is from the arm on the ball, and we have the wave force acting in the down direction. So by resolving our forces in the r and theta direction, we see that the net force in the r direction is equal to m times ar, and this gives us that n cos 30 minus 1/2 sine 30 is equal to m ar, and we can isolate just n in this case, and we see that this gives us that n is equal to 0.279 pounds. Next, what we can do is resolve our forces in the theta direction, and so that net force in theta is equal to m times a theta. There we see that F FOA plus n sine 30 minus 1/2 cosine 30 is equal to m a theta. This gives us an FOA that's equal to 0.3 pounds. And this is our final answer.